Hello, everybody.
Good evening.
Hi there, everybody.
All right. We have a fresh face tonight, and I want to introduce Rick Taft, who has graciously agreed to volunteer with us and help us run the back end of the
We got some
program
echo
tonight.
going.
Yeah, we do have echo. Let's figure that out.
It could be, maybe it's my microphone. Anyway, I'm Rick Taft, and happy to be here tonight, learning how the technical aspects of putting a program like this on. So I'm taking a lot of notes, and hopefully we'll not have any major technical problems tonight.
Well, the fact that we're all here and you see 4 faces on the screen means you did everything correctly. So thank you.
And if we do have any problems, Rick will blame it on you. No,
That's right. That's the main reason you're here.
Yeah, Rick found out tonight why it is that you need a PhD in order to do this work.
That's right. You need a PhD in Facebook.
You know, I have a 3-page checklist of what to do, and I think it would be easier to land a 747 than to set this stuff up, but that's another issue.
Yeah, you're probably right. So, we have good news and bad news. The bad news is that the humidity is at 85%. And that means that we can't run the telescope right now. We're going to keep an eye on it throughout the evening here and see if it takes some precipitous drop, but the weather conditions are not suggestive of that. So we have other programming for you, and that's the good news. But before we get started, I'd like to remind everybody who we are and what we're doing. So we have Gerald McKeegan and Rick Taft, who you met, and John Curry, and we're at the Chabot Space and Science Center, and we're sitting next to Nellie, our 36-inch research reflector telescope, and I'll turn I can't do that while my fake background is up. Hold on for a moment, and let me turn that off. I had that left on from last night.
You can see part of it behind Gerald over there.
And that's not working either. Stand by. Sorry about that, folks. There we go. Now I'm in the right place. There. So you can see our telescope. It's moving. Yes, it works. And
pointing it at various places on the ceiling.
Yes. That's right. You can look for flaws in the paint that way. So anyway, what I was saying, though, is we're here in the observatory with our 36-inch reflector at the Chabot Space and Science Center. Chabot is closed to the public for now, although we are planning on reopening late summer, early fall. And in order to keep our virtual programs going, and in order to keep our facility in usable condition, we depend on donations from people like you. So we appreciate any donations that you might be able to make tonight. I also want to thank our community partner, Fremont Bank, for supporting the virtual telescope program, and to those of you who have donated and participated in the past. So that's the commercial part. So what else have we got tonight, Gerald?
Well, we got a lot of stuff going on, but tonight is kind of a special night. There's an international celebration going on tonight. It's called Yuri's Night. On April 12th of 1961, the first human being flew into space, and that was Yuri Gagarin. He was a Russian cosmonaut. And we've started celebrating this event every year. Actually, the celebrations really didn't start until about the year 2001. And initially, it was a very localized celebration. I think they started doing it in Los Angeles. And they just used it as an excuse to have a party. And so the first couple of years, it was just a kind of a local party, but the news kind of spread a little bit, and more people got involved. They started adding other events to it. Still had the party element. So if you're out there and you've got a bottle of vodka with you, have at it. And today it is now an international event held every year, and we call it Yuri's Night. And it's an international celebration of that first human space flight. We're doing it tonight on the 10th because it's a Saturday night, and a Saturday night is better for international parties than Monday night. Monday the 12th is the actual anniversary, but everybody's celebrating tonight. So people all around the world tonight are celebrating Yuri's night. Coincidentally, like I say, the first human space flight was on April 12th of 1961. Exactly 20 years later was the first space shuttle flight. The space shuttle Columbia made its first flight on April 12th of 1981 with astronauts John Young and Bob Crippen flying the space shuttle Columbia. So just coincidentally, so we're actually celebrating two milestones in space exploration: the flight of Yuri Gagarin in 1961 and the flight of the Columbia in 1981. So that's what the celebration is all about tonight. And we thought it would be good for us to talk about it because here at Chabot, we have a number of exhibits, including several exhibits of space artifacts. So I thought what I'd do is maybe talk a little bit about Gagarin's flight, tell you, what his capsule looked like and give you a few background details, and then show you some of the artifacts that we have here at Chabot, and let you have something to look forward to when we finally reopen. You can come back up and see some of these Russian artifacts. So I'm going to see if I can share an image here. Yeah, I got the wrong image here. Hang on a second. Give me a minute.
Don't worry, Terrell. We'll just blame Rick.
Exactly. I was thinking the same thing.
That's right. Blame the new guy, right?
Yeah.
That's right. That's right. Blame the new guy. All right, here we go. So this is the spacecraft that Yuri Gagarin flew in 1961. It was called the Vostok 1. There was a whole series of Vostok flights after Yuri Gagarin, and this was the first of them. And Gagarin is inside the ball-shaped structure here. This is kind of, think of it as the service module, if you will. And he's kind of laying down inside of here. In fact, I think I've got an image right here. Yeah, there you go. So this shows what it would look like inside. And this part here would actually eventually separate from this lower part and when it was time to re-enter. But this is how it was configured while he was on orbit. Now, Gagarin took off shortly after 9 o'clock Moscow time from the Baikonur launch facility. And he made one complete orbit around the Earth and then returned to the surface of the Earth, landing on the ground in Russia. I'll stop this for a second and find a couple of other images that kind of show you what that looked like. Here we go. So this is what the descent stage looked like when they finally found it. They actually were not able to determine exactly where it was initially when it came back. Tracking in those days was not as good as it is today. In fact, even communications was not as good as it is today. While Gagarin was flying up in orbit, sometimes he could talk directly to ground stations using what we call VHF, which is a radio transmission band that is pretty much line of sight. So as long as he was within line of sight of a ground station, he could talk directly to them. But reception wasn't always real good, so sometimes they would only get parts of his messages, and so he kept the messages pretty short. Everything's going well, everything's fine, and that was about it. But sometimes he was out of range of any of these ground stations for VHF communications, so he had to communicate using HF, which is a different radio band. It's better for long range communication because it kind of bounces off the ionosphere, But rather than communicate by voice on HF, he was communicating using telegraph. So he was telegraphing messages via HF, and the ground control would get some of those messages. Some of them they did not, but all the messages they were getting were saying he was doing fine. So he made his one orbit. He then descended. As he was descending, I'm going to go back to one of these other images here. Bear with me. Get there yet? There we go. Too many buttons to push while I'm doing this.
Yeah.
And they move them around.
Okay.
Yeah.
So in order to descend, you stayed mated up between the descent stage where he was and this service stage here. They stayed connected to each other during the descent, but the last part of the descent before landing, they had to separate. And what was supposed to happen is they completely separate, and one goes one way and just crashes down to the surface. And then the ball-shaped thing here had a parachute on it, and that was going to descend by parachute. But what happened was, if you look carefully, you can see some straps here, and there's another strap here. Those were supposed to disconnect to unstrap them, and that worked fine. But you see here, this is a wire bundle, a cable, a bunch of cables, and for whatever reason, that did not disconnect correctly during just before he was descending. So as they came down, the two of them were kind of flopping around between each other. But because of the heat of reentry, eventually the cable burned through and they separated. But that made for a very rocky ride for our friend Yuri Gagarin while he was coming down. And then there's another element to this story, and it's a really interesting part. In order to qualify as the first human flight, Gagarin had to ride the capsule up and back down. There was a certification agency called the Fédération Aéronautique Internationale. It was a Swiss organization, and they are the ones who set all the rules for setting records in aerospace, at least back in the 1960s they were.
Now Guinness does it, of course.
Well, yeah. But at the time, their rule for being the first human to fly into space and return to Earth required that the pilot stay in the spacecraft for the entire trip. Well, at the time, the Russians weren't sure how to get the Vostok to do a soft landing. They could bring it down on a parachute, but it still came down pretty hard. In fact, when the Vostok, this ball-shaped structure here, landed on the ground, it landed near a farm. And a couple of girls who happened to be there saw it come down, and they observed it to bounce quite a few feet back up into the air and then come back down again. So you can imagine what it would have been like if he was inside the spacecraft at the time that he bounced. But if you look again at this cutaway view, you notice a kind of a structure that he's sitting on here, kind of a cylinder-shaped structure. And then there's this round plate right here. Well, what they didn't tell anybody was that just before landing, still a couple of miles up, Gagarin ejected from the capsule, blew off this hatch, and this entire structure ejected out. And he descended separately by parachute. But that meant that he didn't quite meet the requirements. So for years, the Russians kept it secret that Gagarin had actually ejected from the spacecraft and descended by parachute separately. So that's kind of an interesting side story to this whole thing. Another interesting story that I thought was really funny. Once Gagarin gets on the ground, he lands, parachutes down to the ground. And like I say, their tracking wasn't really good, so they didn't know quite where he was, and he knew before the flight that that was going to be the case. So he gets down on the ground and he gets out of his parachute harness and he's still in his orange flight suit and still got his helmet on. And he starts looking around and he sees a a farmer, a woman and her daughter standing off in the distance. So he starts walking towards them. And of course they see this guy in this orange suit with a helmet on who just descended from the sky, and they're scared, and so they start to back away from him. And he says, no, 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 I'm Russian, everything's cool. He says, but I need to borrow your phone so I can call Moscow and tell them where I am. so, so that's the little kind of funny story about the end of his flight. So I wanted to kind of share with you a couple of other images here. We have several Russian artifacts here at Chabot. And one of the first ones I want to show you is, remember how I said he ejected and I showed you that image of a ejection seat that he was in? We have one right here at Chabot. This is a full-scale model of the ejection seat that Yuri Gagarin used to eject out of the Vostok. Now, that was the first of actually a couple of Vostok flights, and they all use these ejection seats. So this is a full-scale mock-up of the ejection seat, and we have it here at Chabot. We've got a couple other Russian artifacts. We've got a capsule. Let me show you that. Now, this is not the Vostok capsule. This is actually the Soyuz capsule. Vostok was the first phase of their human spaceflight program. As they continued on, they switched to the Soyuz capsule, and a version of the Soyuz is still in use today. So this is a model of the three-man Soyuz capsule. Got some images here looking inside. You can see a dummy inside in a actual Russian spacesuit. We have several Russian spacesuits here at Chabot, and if you were up here, you could look inside the capsule and see that there are three cosmonauts inside the capsule crammed very close together. And that's how they still ride up to the space station in a Soyuz capsule, sitting shoulder to shoulder inside this capsule like this. So something interesting for you to look at when you finally return here to Chabot. A couple of other artifacts that we have, a Orlan spacesuit. Now the Orlan spacesuit is a more modern type of spacesuit that the Russians have been using. They use it on the space station, and it's got a really interesting configuration. The U.S. spacesuit is kind of a two-piece thing. There's the lower part of it and then the upper part of it, and they put their pants on first, and then they put the upper part on second. The Russians don't do it that way. So I'm going to stop my share here for a minute and switch to a different image, if I can find it. All right. Now this is showing the back end of the Orlan spacesuit, and you see it's got a trapdoor in the back end. And in order to get into the spacesuit, the cosmonaut has to climb into the back end of the suit. So this is actually an image on the space station. You see the U.S. spacesuit here, but this is one of the cosmonauts trying to climb into the back end of the Russian Orlan spacesuit. And so you can see how different that is. So the backpack, with the oxygen tanks and all the cooling equipment and everything, that's part of the backpack. But that whole backpack seals up, and he climbs into this hole when he gets into the spacesuit. So that's pretty cool. So got a couple of other Russian artifacts that I wanted to show you. Actually, just one more artifact. Going the wrong way here. You'll really like this one.
I know what this is going to be.
Okay, here's a strange contraption.
Ah,
This is a Russian space toilet. This is a toilet similar to the one that was used on the Mir space station. It's not too dissimilar to the one that's was used that is being used on the International Space Station either. So this is a very complicated toilet. You know, it's a lot different trying to go to the bathroom up in space. And so this is how we do it. Uh, Here's a shot of the business end of the toilet, and I'll let you figure out how it works. But this is one of the artifacts we have here at Chabot. So, you can think about it for a while, and then when Chabot reopens, you can come up here and see if you can figure out how a cosmonaut or an astronaut would use the space toilet. I will not explain it to you. Okay. So anyway, we just thought we'd share some of this to kind of celebrate Yuri's night up here at the Chabot Space and Science Center.
well, that was pretty good.
It was. Happy Yuri's
Yeah.
night, everyone.
Yeah.
Happy Yuri's night,
Yeah.
that's right.
Yeah.
I have one announcement here, and I have to find it on upcoming events. So we have a meteor shower coming up, and those are the Lyrids.
Oh yeah.
And they're coming on April 22nd. And they're always called the April shooting stars. And it's known for bright fireballs. And you see about 10 to 20 meteors per hour. And the nice thing about this meteor shower is, unlike most of the other notable meteor showers, the radiant, where it appears that the meteors are coming from, the radiant is very high in the sky just after midnight. So if you venture out after midnight on April 22nd, all you have to do is look up, and that's where the radiant is. And of course, you don't have to necessarily be up really, really late or really, really early in the morning. You could just, assume that there will be a higher number of meteors in the 24 hours in front of the 22nd and the 24 hours following the 22nd. But anyhow, that's coming up.
Well, speaking of things flying around in the sky, we've got another couple of things coming up here. Tomorrow morning, about just after midnight, about 41 minutes after midnight Pacific time tomorrow morning, we got an asteroid that's going to pass sort of close to the Earth. It's going to be 97% of the distance between the Earth and the Moon. So that's actually pretty far away. And it's somewhere around 8 to 10 meters in size, just discovered a couple of days ago. So that's going to happen. But even more interesting, on Monday at about 6 o'clock in the morning, Pacific Daylight Time, we have another asteroid, a little bit smaller one. This one's only about 5 or 6 meters in size, and it's going to come really close to the Earth. It will be closer to the Earth than the geosynchronous satellites, but it will miss the Earth, so there's no danger of any impact or any harm coming. But it's kind of cool to know that these asteroids sometimes get pretty close to us, and they fly around a lot. The one on Monday, that will be the 38th asteroid that we know of that has passed the Earth closer than the Moon since January 1st of this year. So that event actually happens several times a month, that we get asteroids passing pretty close to the Earth. Fortunately, almost all of them miss us, and even the ones that might be a threat to us almost all of these are very small asteroids that would burn up in the atmosphere before.
Gerald, what distance from the surface of the Earth is that one going to be? Do you have that?
You mentioned the geosynchronous satellites, but most people probably don't know what that is.
Geosynchronous satellites orbit the Earth at about an altitude of about 22,000 miles. This satellite or this asteroid is going to be about 16,000 miles from the center of the Earth. So that's only about 12,000 miles from the surface of the Earth. So pretty close.
Yeah, that's amazing.
Yeah, but it's not unusual for asteroids to come close to the Earth like this. It happens many times a month. And, almost all of them are small, harmless asteroids that would burn up if they entered the atmosphere. Almost all of them.
Isabel has a telescope question, and she wanted to know if an 8-inch Dobsonian telescope is good for deep sky objects like the Messier objects, and the answer is absolutely yes.
Yes,
that's
absolutely.
In fact the perfect telescope for doing the Messier objects, and then you can even go for dimmer objects than the Messiers and work on the Herschel 400 and get most of those as well. So an 8-inch Dobsonian telescope will keep you busy for years.
I see another question here. Why does the Soyuz get to the International Space Station quicker than when it's launching from Kazakhstan? That all has to do with the position of the launch site relative to the orbit of the space station. The closer you are to being directly under that orbit, the easier it is for you to get to the space station, the faster you can get to the space station. And also it has to do with how fast the Earth is rotating at that point when you launch. If you launch straight east from Cape Canaveral, the orbit is only going to be inclined about 28 degrees relative to the equator. So in order to get into the orbit that you need to chase after the space station, you have to use a very different launch angle. You can't launch straight east. And the reason we like to launch straight east is because we get the maximum effect of the Earth's rotation. So, the Earth is rotating at the latitude of Cape Canaveral. You're moving about 900 miles an hour as the Earth rotates. So you get that extra boost when you launch. But if you can't launch straight east, you lose some of that extra boost. So there's several factors that go into how long it takes you to get from orbit to or from the launch site into orbit, and then once you're in that orbit, how long it takes you to catch up with the space station. So it's just a matter of launch site and orbit configuration.
What happens if the ISS is in the way of an asteroid?
Well,
this is why Gerald is up all night tracking asteroids. He's personally saving the ISS.
Yeah, this is exactly why we do this. What we try to do, just to kind of clarify here, the telescope that you see behind me, the 36-inch telescope here at Chabot Space and Science Center, is actually part of a global network of observatories that searches for and tracks near-Earth asteroids. So the objective of all that effort is to discover these asteroids before they come close to the Earth and figure out what their orbit is and which way they're going. And if we do happen to see one that's going to be a threat to the space station, we can alert the space station crew and have them adjust their orbit so they basically get out of the way. And that's true not just for asteroids, it's also true for space junk, and even some small rocky objects that are in orbit around the Earth. anything that we see that might be a threat to the space station, if we can spot it ahead of time, we can alert the crew of the space station and they can adjust the orbit to basically get out of the way. So that's one of the many reasons why we like to track these asteroids, is for that very purpose.
Yeah, they're constantly keeping track of space junk, and that might be getting in the way of satellites and the ISS, and there's constantly maneuvers going on to avoid collisions with that. For those that tuned in late, the reason we're not live with the telescope tonight is because our humidity is at 90%. So the temperature is 44 degrees up here at the Chabot Space and Science Center, and the dew point is at 41.8 degrees. So as you can imagine, we're getting close to the maximum humidity that's possible. So we're not able to open the telescope when it gets beyond 85% humidity. Otherwise, moisture collects on the primary mirror, and that's a big mess to clean up. So sorry about that.
All right. Any other questions?
Oh, this is a good one. How many sites and telescopes and views do you need to calculate the path of an asteroid?
Good question. Yes. So to get a very rough estimate of an asteroid's orbit, we need only 3 data points. So if we were to be looking at the sky with this telescope and we happen to spot a previously unknown asteroid, we would get 3 data points, maybe a half an hour apart. And that's enough to give a very rough estimate of the orbit. But what we really want to do is be able to track that asteroid for at least 48 hours. So the standard that the Minor Planet Center uses, the Minor Planet Center is a function of the International Astronomical Union. The Minor Planet Center is the clearinghouse for all incoming asteroid data. They are the ones who assign designations to the asteroids and so forth, and they are the ones that publish the orbits. And their requirement for, in most cases, is that they have at least 48 hours worth of observations before they will decide that they have enough data to post an accurate orbit for the asteroid. But that's not always the case. If I spot an asteroid and I track it, say for an hour, and based on my very limited data, it appears that that asteroid is going to hit the Earth or hit the space station or somehow or other cause a problem, they may shorten that window. They'll try to get observations from 1 or 2 other observatories, but they'd rather err on the side of being too cautious rather than not being cautious enough. So the normal procedure is they need 2 days worth of observations, but if it's something that's a potential threat, they may shorten that window. There have been a couple of cases over the last several years where there has been less than 24 hours notice between the first observation by the first observatory that spotted the object and the time that object entered the Earth's atmosphere. And sometimes we don't see it coming at all. In 2013, the asteroid that came down over Chelyabinsk, Russia, we didn't see it coming at all. So generally speaking, about 2 days, and we'd like to have about a dozen or so positional observations in order to get a reasonably good orbit calculation. And lots of math.
Yeah, a fair amount.
Yep.
Stephen asks an interesting question. Does NASA have any space probes that can rendezvous with asteroids that pass close to Earth? Probes are sent to comets and asteroids much farther away at great cost. Wouldn't studying closer asteroids be possible?
The problem is the closer it is, the less of a time window you have in order to get to the asteroid and study it. So when an asteroid is very far away, you can launch to it and you have time to make small changes to your trajectory so that you can rendezvous with that asteroid very accurately. If you try to do that when it's too close, you don't have enough time to very precisely rendezvous with it, and you may miss it. So that's why, like we just had a spacecraft taking samples at the asteroid Bennu. Bennu is a near Earth asteroid. In fact, it's predicted to come pretty close to the Earth. But they waited until they had enough data over a couple of years before they decided to go out and go after it. And they waited until it was fairly far away from the Earth. So they had time once they launch to make small adjustments to the spacecraft trajectory so that they can rendezvous with it, stay with it for a while, take their samples and so on, and then come on back to Earth. So that's why we like to do it when it's far away. Now, if we wanted to deflect an asteroid, we definitely want to do that when it's far away, because the farther away it is from the Earth, the easier it is to deflect it so it doesn't hit the Earth. Because if it's really far away, you can deflect it over a very small angle to get it to miss the Earth. But if it's very close to the Earth, you have to deflect it over a very large angle. And, that's why we like to find these asteroids years before impact rather than hours before impact.
Yeah, these space missions take months and years to plan,
Right.
and you just don't have the time to do a quick launch in a hurry if you have to.
Steve brought up an interesting fact, and he says that the inclination of the ISS orbit is 51.6 degrees. And that orbit was picked because it is the smallest inclination that allows you to launch from Baikonur, Kazakhstan, and not cross the Chinese border.
I saw that. That's very interesting.
Yeah.
I love that.
Yeah.
Yep. Politics, even in space flight.
Even in
Absolutely.
space. No getting away from it.
Yeah.
All right. Other questions? Anyone else?
Let's see.
Dwarf planets.
Isabel asks, is the humidity too high? Yes, it
Yes.
is. It's at 92% now. So
Yeah, it's not getting any lower.
Yep.
Sometimes, it'll get up to 85, 86, and then it will decide to drop.
Yeah,
But not tonight.
We have a very frustrated telescope operator up here tonight, somebody who's being trained on this telescope, and he's sitting behind me over here. I think you can see him there. Say
And
hello.
he looks really depressed about this current humidity situation.
The plan was to have him
Currently
open the telescope and
92%.
operate the telescope tonight because he's being trained on the telescope, and unfortunately he did get a chance to practice opening and closing the observatory, but that's about it. So,
Unfortunately, as soon as we opened the door, the humidity started going back up again.
Yep.
Just happens every time.
So Mike Duran asked, how has Elon Musk's Starlink impacted viewing? And this is a good segue to an event that's coming up pretty soon. I'll let Gerald mention that. But before he does, the answer is that it has impacted us considerably. And for those of us who do astrophotography in the early evening and early morning, we have a longer period of time where satellites are visible and interfering with the images. So our night has been cut by a couple of hours.
Yeah, you guys are too close together. You're getting
that might be the problem. That's better. Thanks for.
Yeah.
We hadn't thought about that. So the Starlink satellites are going to be numbering in the tens of thousands. I think the final number is going to be something like 60,000, and they do reflect sunlight. So while you're taking images, there is a good possibility that satellites will streak through the images and leave light artifacts behind. A lot of those can be processed out. We have all kinds of tricky software that gets rid of those types of of streaks, but it becomes harder and harder as the concentration of those satellites goes up. So it's a great question. And Gerald, why don't you mention what's coming up in a couple of weeks?
All right. Well, the other thing too is when you start getting that many satellites orbiting around the Earth, it actually increases the amount of what we call sky glow. So even today, especially if you're near a city and you look up at the night sky, you don't see very many stars because of what's called sky glow, the light from the ground, from the street lights and the headlights and advertising sign lights and the front porch lights and lights that are just out there because they're cool. All of that light shines up into the sky and reflects off of the atmosphere back down to us, and we see it as sky glow. And that sky glow prevents us from seeing most of the stars. And even for astrophotography, and even for things like trying to track asteroids, sky glow is a problem. So, it's getting worse because of some of the choices we've been making in terms of outdoor lighting. And to talk about that, I guess it's 3 weeks from now, it's the 23rd. No, that's 2 weeks from now. No, it's 3 weeks. 2 weeks. 2 weeks.
2 weeks.
Yeah. God.
Make up your mind.
Yeah. Yes, I did take math in high school. So, in 2 weeks, on Friday, the 23rd of April, we are going to do a special program about light pollution. It will start at 7 o'clock, and it will be on our Facebook and our YouTube channel. And we're going to show you a movie. There was a guy, his name is Sriram Murali, and he produced an excellent movie about light pollution. And parts of it was filmed here at the Chabot Space and Science Center. It involves a number of interviews with both Richard Oger and myself, along with some other EAS members. But it's very much an international film. He went around the world filming at different locations and showing the effects of light pollution, not only on astronomy, but on wildlife and on public safety and on human health. And so this film includes interviews with lots of different experts on this topic, shows lots of examples of good outdoor lighting versus not so good outdoor lighting, and really drives home the effect of sky glow and light pollution. And so it's going to be really interesting to see that. Again, that'll be on the 23rd of April, starting at 7 o'clock. After we show the film, we're actually going to have a Q&A session with Sriram, the producer of the film, who's currently in Singapore making another movie. And also with a gentleman from the International Dark Sky Association, Andy, and I forget his last name, Richard. I think his first name is Andy.
I don't remember. Yeah,
we'll figure
Andy.
it out by the 23rd.
Andy from the International Dark Sky.
Sorry.
And Richard and I will be on also. And so we'll be taking questions from the audience, just like we're doing tonight. But I really encourage you to watch this. It's a great movie. It's very well made, and it's an eye opener. If you don't really understand the effects of light pollution, this will be a real eye opener for you. So I encourage everybody to tune in on the 23rd of April at 7 o'clock Pacific time that evening and check us out.
Good.
All right.
Hey, speaking of taking questions, is it true that the Mars helicopter will only operate for about a month or so? And if so, why? Yeah, it is true. That helicopter was basically just a test to see if they could do it.
Right. And originally it was supposed to fly shortly after midnight our time tonight, but I understand that they ran into some problems, and so they've delayed it until the April 14th for the flight. But the plan was only to operate it for a couple of flights. Maybe I recollect about 2 hours worth of flying time altogether. And it's purely a test, like John says. So just to see if it will work and see what they can do with it. Because Mars is so far away, they can't fly it manually.
Yeah. So next time around, we'll have a production model that does a lot better. But this is just a test.
Off and again.
Hey guys,
And this time I didn't eat a granola bar.
So got a couple more questions regarding the Starlink satellites. What's the operational lifetime of a Starlink satellite? And do you think they're going to become space debris one day?
I don't know off the top of my head how long they will last, but yeah, I do think they're going to be space debris. And interestingly, we talk about Starlink right now because that's the program that's already started. They've already started launching satellites. We've got several hundred of them up already. But there are other companies proposing and planning to do the same thing. So there could be tens of thousands of these small satellites orbiting the Earth, and unless there is some mechanism on board the satellite to deorbit the spacecraft or the satellite once it reaches the end of its life, it'll become space junk. And that does pose a problem for us in the future as we want to launch other satellites, weather satellites, or communication satellites and so on. We're going to have to deal with that. And also, things like the space shuttle, the space station, those flights, other flights, we're getting ready to go back to the moon. So we're going to have to take that into consideration as well. So it could be a problem, not just for us astronomers down here on the ground, but all kinds of different organizations may run into issues, and so far, the response has been, well, we'll figure it out and work our way around.
Pretty tepid response.
Typical, yeah.
I'm gonna guess that the Starlink satellites are the lifetimes of those are in the 5-year range, 5 to 7 years, and the Iridiums were 7 to 10, and these are lower orbit. So,
yeah, the Iridium, so they had a way to deorbit them. I'm not sure about the sky.
yeah,
Starlink
I don't know
satellites.
about these. I don't know what the plan is. I haven't read anything.
Well, the big communication satellites, the geosynchronous communication satellites, their typical lifetime is about 15 years.
Yeah.
But those are big satellites.
They're big and they're far. Yeah.
They carry a lot of fuel on board. They have very robust power systems. These small Starlink satellites, not nearly as powerful.
Yeah, and they are tiny. They will burn up easily in the atmosphere, but still.
Related question. Richard asks, how long is the ISS expected to remain in orbit?
Oh, that's a good question.
Well, it's supposedly the International Space Station mission will end in 2025. That's under the current agreement between the partners countries on the space station. But I suspect as we get closer to that date, it's going to get extended. Unless there's something wrong with the space station, there's no reason not to keep flying and keep using it.
So it's a political question.
Well, sort of. Well, also it's
it always comes down to money, doesn't it?
Yeah.
There's a long note from Bob Schock about the Starlink satellites there. He says, Musk notes that the existing satellites on orbit will have a relatively short lifespan, meaning while they won't have the treatment, whatever that means, they should only be in use for around 3 or 4 years before
so I was right about that. Yeah.
And he says being just deorbited. So I guess they have some mechanism for doing that.
Well, the good news is that
Maybe.
if we end up as a civilization rejecting the notion of having 100,000 satellites flying around the Earth and ruining the night sky, it's only a 3 to 5 year wait till they're all gone.
Yeah, but what
Yeah,
about the ones that go
yeah,
up to replace
yeah.
them?
Well, I mean, assuming that they're not replacing, but actually, it sounds like it might be a really pretty cool system, also. So it's gonna be a lengthy, difficult discussion.
All right. Well, let's see. Do we have any other astronomy or space related questions that you want to ask? Now's the time. We can't operate our telescope tonight, so we're winging it a little bit. So if you've got those burning questions,
We've got one from a 7-year-old.
oh, good,
Gerald, one of
good.
your favorites, wants to know, how much mass does a black hole have?
Ah, it's a good question because there is not a single answer. A black hole can have only about the mass of one sun, or it can have the mass of up to 6 billion suns or more. So it really depends. Right now, there is a black hole at the center of the Milky Way galaxy. Its mass is about 4 million times the mass of the sun. But we've also been talking a lot lately about M87, another galaxy with a very powerful black hole at the center. Its black hole has, I think it's 6.4 billion with a B times the mass of the sun. So black holes can have different masses. They don't all have the same mass. And one of the interesting things about a black hole is the size of the black hole is proportional to the mass. So if you double the mass of the black hole, of the singularity at the center of the black hole, the size of the black hole doubles. And that's just because of the way the mathematics works. So your answer, there is no one answer to your question. It's a really good question, but there is not a single answer to that question because it depends on the black hole.
A good question here from Leah. What is the difference between the telescopes here in Chabot and the ones at the Lick Observatory? I'm not
Oh
sure where
gosh.
we would start.
Yeah.
And we have a variety of telescopes here, and Lick has a variety of telescopes as well. Both institutions have historical telescopes. So the Lick Observatory is known for its very large refractor telescope, and I believe that's a 30-inch, right? That's a 36-inch
36. Yeah.
refractor, which is the same diameter as Nellie here. But we also have long refractor telescopes. We have Rachel, that's a 20-inch refractor, and we have Leia, and which is an 8-inch refractor. And so those scopes are kind of similar in their age and the purpose for which they were designed and built. And Lick also has very large reflecting telescopes that are research telescopes.
Like
So,
Nellie.
like Nellie, except 3 times the diameter of Nellie. So there's, Lick is a very well-funded and fairly old institution and has accumulated quite a bit of astronomical instruments over the last 100 years or so, and is run by the University of California. We have our 3 main telescopes here, and so it's a little more limited, but it's still a similar cross section of the available technology. You're muted, John. Sorry. Yeah,
Oh, sorry about that. I
that's
believe
all
the
right.
36-inch at Lick is an Alvin Clark telescope, is it not?
Yes. Yes, it
That's
Yeah,
is.
right.
and that's
Yes.
very, very similar in time frame to our 8-inch Leia, which is also an Alvin Clark
Alvin
telescope.
Clark. That's right.
Yeah. Yeah.
Good question.
Yeah, yeah. And unlike Chabot, unlike Lick, Chabot, once the pandemic is over and we get back to normal business, you can come up to Chabot and look through our telescopes every weekend. We open the telescopes on Friday and Saturday nights for free public viewing. Lick does not do that. They occasionally open a couple of their telescopes for public viewing, but I think it's only like once a month or something like that.
Yeah,
It's a limited basis.
that's right. It's a once a month program that sometimes it's accompanied by music, and it's the 36-inch refractor that they usually open up to the public.
Hey, here's a good question from Isabel. Have you ever seen dwarf planets? Yes, we have.
Yes.
In fact,
Seen Pluto.
We've seen Pluto with this telescope.
Gerald, are you coming around now?
No,
you're willing to accept Pluto?
No, he said dwarf planets.
Yeah. Remember, I don't say Pluto. I say Pluto is a planet because it is a dwarf planet. My issue is with what we are calling planets and what we are not calling planets. I think they're all planets. So
I sense some verbal gymnastics going on
here. Yes. So when somebody asks me how many planets are in the solar system, I say there are millions of planets. There are terrestrial planets. There are Jovian planets like the giant planets, Jupiter and Saturn and so forth. There are dwarf planets like Pluto and Ceres and Eris and so on. And then there are all the minor planets, the asteroids and the comets. And when you add them all up, it's actually millions. So when somebody says, how many planets are there in the solar system? Since all of those different categories have the word planets in it, I say there are millions of planets. So,
right.
And I'm a majority of one.
Yeah.
Here's a question. Are we going to image the lunar eclipse on May 26th?
We're
going to have an event that night, right?
Yes, we are planning. Definitely, we are going to put a camera on the telescope and be able to image it. There is some discussion about actually having a very limited number of guests up here at Chabot during that event as well. So stay tuned. We're still discussing that, but yes, on the 26th, early in the morning of the 26th, there will be a full lunar eclipse. The moon will pass through the shadow of the Earth, and so the moon is going to turn rusty red, and we are definitely going to carry that on our YouTube and Facebook channels with a camera on the telescope, but we may also do a very limited on-site event as well. So stay tuned.
Here's a question from Bruce Willis. Oh no, this isn't from Bruce Willis. It's from Stephen.
Wait a minute, really? Hey, Bruce, what's your next movie?
The question is, would nuclear explosions be used to deflect an asteroid?
They could, but not quite the way Bruce Willis would do it. Yeah, you would not want to bury a nuclear weapon inside of the asteroid. You would want to explode it next to it. But that is probably the least desirable way to deflect an asteroid. There are much better ways that are less likely to blow the asteroid apart. What we don't want to do is create a situation where instead of one big asteroid, we have 5 or 6 smaller but equally dangerous asteroids heading our way. So the nuclear option is actually the least desirable option.
So what you're saying is that was a terrible movie.
Oh, it's a good movie. I liked it.
You liked it. Yeah.
Let me tell you a story about
the movie.
Let me tell you a story about the movie Armageddon. Okay, so for those of you who don't know, I think there may be only a few people out here who don't know about this. There was a movie made in the late 1990s called Armageddon, which starred Bruce Willis, Ben Affleck, and Billy Bob Thornton, I think, was in it. And it was supposedly a asteroid was threatening the Earth, and so Bruce Willis, who was not an astronaut, he led a team of oil firefighters, oil drillers or something like that. So anyway, they ended up flying a modified space shuttle up to the asteroid, drilling holes in it. A couple guys got killed along the way, and blowing it up with nuclear weapons and saving the Earth. It was a horrible movie in so many ways. And I'm going to get an email from Michael Bay now for saying.
No, you're going to get an email from Bruce Willis.
Probably.
But the movie was so, from a technical standpoint, it was so bad that for a while NASA was using it to kind of test their managers, and they would have them sit down and watch the movie and take notes how many things they could find wrong. And a NASA employee told me once that there were something like 50 science or engineering errors in the first 30 minutes of the movie. So, but it was entertaining. It made a lot of money at the box office, so they're not complaining too much.
Yeah. All right.
Much better. Impacting the Earth movie made almost at the same time was one called Deep Impact, and it was still pretty far-fetched, but technically it was a little bit better.
It had a few technical problems with that too.
Yeah. Hollywood tends not to do asteroids very well.
Or astronomy in general.
Astronomy in general, but Hollywood does not do astronomy very well, and it certainly does not do asteroids very well.
Leah asked a follow-up question to her observatory question earlier. Is it unusual to have two observatories so close together, Chabot and Lick? I would imagine they're both affected by the same weather and seeing in the same part of the sky. Sure, we're affected by the same weather. I mean, if there's a storm over Oakland, it's probably cloudy over San Jose. But it's not unusual. It's not unusual for observatories to be grouped in the same parts of the world. So if you go to Chile, it's like observatory city. There's an observatory every mile, and if you go to
Hawaii,
the big island of Hawaii, that's right. There's a half a dozen observatories at the top of Mauna Kea, and because it is a great place to have an observatory for lots of reasons, and I don't know if the Bay Area is a great place to have an observatory, but there's certainly lots of people interested in astronomy and lots of institutions that are wanting to support the study of astronomy. And that is the reason that Chabot exists, and that is the reason that Lick exists.
Yeah, and just for the record, Lick does not get the same weather that we do. So, for example, we're at 94% relative humidity right now. I bet you up at Lick, it's at least 20% lower.
Because of the altitude.
They've got some altitude on us.
Yes. Plus, they don't get the direct inflow of the marine layer that comes through the Golden Gate like we do. If you look at a map of the Bay Area, you can draw a straight line from the Golden Gate straight across the bay right at Chabot. And so when the marine layer comes in, it's got us right in its sights. And often we are literally inside the fog, whereas San Jose and Lick and all that, they're clear. So the weather is a little bit better up there on Mount Hamilton.
Yeah, that makes sense. There's another observatory nearby us as well, which is less known, less talked about, and that's the Lauschner Observatory. And that's over by Orinda,
Lafayette Hills. It's in the Lafayette Hills.
And that's an interesting observatory. It's run by UC Berkeley, and it's got an infrared telescope. So it's set up to study longer wavelengths of light, and that's a more rare type of instrument. There's not as many of those on the ground as a regular optical instrument.
Now, is that telescope open to the public?
No, it's not.
No.
It's research only.
Yeah, that's the one big advantage of Chabot. It is open to the public. So Lick has got some amazing instruments, but we have 3 amazing telescopes that you can see through pretty much any Friday or Saturday evening, weather permitting and COVID permitting as well. Hopefully that'll be soon.
Once we reopen again, yes. We hope that'll be soon.
Yeah.
Hey, there's another question here too about asteroids. And the question
Well,
amateur astronomers make an impact.
not sure what happened there, Rick, but I lost your audio there.
Yeah, I did too.
You want to try to answer that question again?
Yeah, let's see if the audio is working now.
Yep.
Can amateur astronomers make a difference in hunting for asteroids or
Yes,
doing asteroid research?
Yes, they can. I mentioned earlier that there's 300 plus observatories around the world that are doing asteroid work. Quite a few of them are actually amateur telescopes. So there are a lot of amateurs who have invested a lot of money to have a really good telescope in their backyard, and to put all the the associated equipment and computers and everything, and get themselves registered with the International Astronomical Union as official observatories. There's one in particular that I communicate with every once in a while. It's run by a guy named Peter Birtwistle, and he lives in England. He's about 40 or 50 miles outside of London, out in the country. And he has a 16-inch amateur telescope in his backyard. He's got a little dome that he built back there, right up against his back fence. And he is one of the most active asteroid observers in the world. How he manages to do that plus have a full-time job, I don't know, but he does it. He's on there a lot of times, and despite the fact that he's in England, he seems to get good weather quite often. So
it sounds like he's got some good equipment too. But
yeah.
If someone in the Bay Area, for instance, wanted to get started looking for asteroids, what would the minimal equipment be required to do that?
If
8-inch, 10-inch?
Yeah, I would say at least a 10-inch. And if you're in the Bay Area, if you're in an area where you have a lot of light pollution, it's going to be tough.
Mm-hmm.
Now, we use a system in astronomy for describing how bright an object is in our images. We call it the magnitude system. And, the brightest object would be magnitude 0. Magnitude 1 is 2.5 times dimmer. Magnitude 2 is 2.5 times dimmer than that, and so forth. We routinely discover asteroids that are at magnitude 19, magnitude 20, magnitude 21, or sometimes even fainter than that. So we're talking about extremely faint objects, and you need a larger telescope to view those. So it would be a challenge if your objective is to try to search for asteroids or track newly discovered asteroids. It's almost beyond the reach of most amateurs unless they want to buy some really good equipment and put it in a good location. However, in addition to tracking the asteroids, we need also to get other information about them. And that includes the rate of rotation of an asteroid. And if possible, even the orientation of the rotation. And that can be done with some fairly modest amateur equipment. And there are quite a few astronomers who do that. And that's a whole separate part of the asteroid community, is people who just work on determining the rotation rates of asteroids. All right.
All right. That's pretty good.
Thanks.
We made it to 10 after 10, Gerald. And I'm sorry we couldn't open the telescopes tonight, but we had a lot of cool stuff to show you. And I want to thank you all for your questions. It was a good group tonight. Same time next week.
Yep.
And we'll give it another shot. Yep.
Once again, we want to remind you, the Chabot Space and Science Center is closed to the public now because of the pandemic, but we are still providing virtual programming like what you're watching tonight. We do programming several times during the week, and we're also doing work within the facility. There's construction work going on right now. Plus, we're developing some new exhibits, getting ourselves ready for when we finally do reopen. And all of that, of course, requires funding. Since we aren't open, we're not getting the usual funding source of the revenue for ticket sales and so forth. So we are relying a lot more right now on donations. So if you can take a moment to click on that donate button on the Facebook page, or if you want to go to the Chabot Space and Science Center website, chabotspace.org, and you'll see a donate button there at the top of the web page. Click on those donate buttons and help us out with a few bucks. We greatly appreciate it. And if you're associated with a company or organization that supports nonprofits, by all means, introduce them to us or introduce us to them, and let us see if we can't get a few corporate sponsors as well. All right, we got Fremont Bank, they're in there, but we would like to get a few more. All right.
All right. Well, thank you, everyone.
Okay. Anybody having a Yuri's Night party out there? I just want to say salute.
Yeah.
Dos
All
Vidania.
righty.
Dos Vidania. Yeah.
Those done. All right. Good night,
All right.
everyone.
Good night, everybody.
And so you want to end. No. Go back there. There you go.